Alright, so let's have a look at this first question, very unfamiliar. So what have we got here? This thing here. Yeah, so we got this, they're showing you a sketch of a diagram, which is like some, what's it called, quadratic. And yeah, just take a second to read it. Right, so it's y equals x squared plus ax plus b, so we don't know a and b. And it goes, the graph crosses the x-axis at 2, 0, 4, 0. Gives you a little sketch, and you can see where it crosses, here and here. We have the coordinates of this. And you've got to work out the value of b. 4-mark question, by the way. Very unusual, not what you're kind of used to. So there are a few different ways of doing this, but one thing in particular, which I want you guys to kind of be focusing on, is the fact that whenever they give you coordinates, you've got to think they're giving me an x and y combination that works for the, the equation of the curve. That's the way you've got to see this. And now basically, if you can think like that, the rest of the question, once you stick it in, sort of solves itself. So here's what you do. You've got y equals x squared plus ax plus b. And we know that x equals 2 and y equals 0 is your first x and y which make this balance. So if we plug that in, put that in for 2, we get 2 squared here, plus we get 2a here, and we're replacing this, and we got b. So can you see that ends up giving us 4 plus 2a plus b. So just remember that. Here's our first equation. Okay, that's our first equation. Now let's just go back and let's plug in the second one, where we know that x equals 4, y equals 0 also works for this. So if you shove that into there, you're going to get 0 equals 16, because that's 4 squared, plus 4a plus b. And here's our second equation. And look, it's a case of we need to now find b. But do you notice this? We've got two equations which have a and b in. So if I just rearrange this one to make, move the 4 to the other side, what you're going to realize is this is and this one, if I do that as well, I get 4a plus b equals minus 16. I've got simultaneous equations, and the b's already matched. So if I call that 1 and I call this one 2, we could just do 2 minus 1 to make the b's cancel. I know we're trying to work out the value of b, but if we find a, it'll still make it easy to cancel them anyway. Oh no, that's going to be, what am I talking about? Yeah, that's a smart thing to do. Ignore what I said. But yeah, you do 2 minus 1. So can you see 4a minus 2a is going to give you 2a. The b's will cancel. And then you're going to get minus 16. Minus 16 minus minus 4. So that'll give you minus 12. So you find out that a is minus 6. Now all you've got to do is just shove it back into one of these formulas. It doesn't matter which one. So 2a, that's going to give you minus 12, plus b equals minus 4. Add 12 to each side, and you got b equals 8. Okay? So there you go. It turned into a simultaneous equation thing. But listen, the main thing, if they ever tell you a bunch of coordinates, and then oh, it's 7, 10, or whatever, you're like, I've got a value of x and y. Sob those values in. This is the exact same thing we do with, when we do the y equals mx plus c, once we've found the m, so say we've got y equals 3x plus c, and we're trying to find c. And remember, all these questions always tell you, oh, the line passes through, I don't know, minus 2, 5 or something. This is your x value, this is your y, and you just sub them in, and then you find, the c will pop out. Okay, so hopefully that makes sense. And not only are you focusing on answering this question, but every single time you see a coordinate, you're like, you know what to do.